What if I told you you could build your own production grade MCP OCR server right from scratch in under 1 hour using Python, Tesseract and the model context protocol? This is not a basic pytesseract script. We are talking about an actual microservices that can take images, raw file, byte stream and return back clean and extracted text. In this video, I'll guide you step by step through how I build an open source MCP OCR server that is also getting some traction. About 2000 people have been using it and it's used by devs in real project. By the end, you'll have your own version of running it locally or even on the cloud. So it's fast, modular, async, and yes, it works on VS Codes too, or even in the cursor. So stay tuned and we'll show you how I have been using it in the open source client like Grey Goose, and it was able to discover the tool and was able to perform the OCR. Stay tuned. Let's start with the implementation. We are going to initialize the dependency first. So let's do that. We'll do uv init venv. No, let's do uv init first. This will initialize the pyproject.toml, and you can see these things are being added. Now install. Let's do uv add. So for this we need MCP CLI, and we need pytesseract, we need OpenCV Python, NumPy, below HTTPX, alright, so it says an error. Let's see, let's follow the documentation. Okay, it's MCP. So now the dependency are getting installed. Our all dependencies are done. Let's look at the pyproject.toml, and we can see that we have our MCP. For creating our MCP server, our dependencies are installed. Perfect. Now let's start creating the project structure. We'll create an src directory, and inside that we are going to create the tender init, and then we'll also create main.py, and for another file which is server.py. So now we are going to start the implementation. So first thing first, let's import the dependency. Let's make a simple docstring which says MCP OCR server implementation. Here the docstring is is important when you are building the MCP for developer as well as for the LLMs. Now let's import few important things from typing. For type validation, import any optional union, because we are going to support multiple options. So now let's import CV2, import numpy as numpy, import pytesseract from mcp.server.fastMCP, import FastMCP from mcp.shared exceptions, because we need to also handle the any error that is occurring. Since it is in prod code, so we'll have to make sure that the code does not break. MCP types, import error data, internal error, internal params. We are also going to import HTTPS, because user can also provide a link from internet as well. So import URL libs, because we also need to sanitize or parse the URL. enum, let's import enum. And import subprocesses to handle multiple requests. Let's import system. So once these things are done, we'll start doing the implementation. So base thing is, for this code to run, we need to ensure that the server has Tesseract. So we need to first implement a logic that if Tesseract is available or not. And let's give it a log string, check if the Tesseract is installed and accessible. So let's make a try catch, try an exception. We'll run subprocess dot run. So this will execute the shell scripts. So we'll C double S E R A C T comma version. So doing this, I'll show you what it does. Capture output is equals to true, check is equals to true. I mean, this should be a truthy, and if it does not works, then subprocesses dot call process error, file not found error. File exists? No, it should be file not found. And then we can just, for now, let's print if C Tesseract not found, and then we'll attempt to install it, because we get this exception. And that's why this is a prod level code, because we are going to do the installation as well. System.stdr. So then we'll implement one more function, which is let's make one separate file here, and this would be install. Install Tesseract.py, and inside of it we are going to implement various methods that will do the installation as per any environment that we are running this script. So let's make a dummy function right now here. So def install Tesseract, and let's pass it for now. We'll come here from install. What was it? Install Tesseract. Because they are in the same level. So let's come here for now. We will right away implement it, so we'll just call it install Tesseract, and as soon as this script is called, we'll make this execution. So this will ensure our MCP server will be running correctly anywhere. Now let's implement the Tesseract installation. So let's first build a package manager. And it is going to return str, and Python is complaining, so we'll import from typing. Yes, so that's fine. And here we are going to detect the system itself first. System package manager. So like, is it using Windows or Mac, or any systems? So for that we'll have to import the platform. So now let's get the system. So platform dot system dot lower. So this way we'll get the system. Now we'll see if subprocess. So we'll also need to import subprocess. So let's check one by one which system, if depending upon the Darwin, Brew, Linux, apt or DNF, we are going to check if their bin exists, user binary exists. So now let's do installation. Let's do a simple if system equals to Darwin, then we are going to check if the homebrew is installed. Because that's the easiest way to install pytesseract. So again, let's execute subprocess dot run now. So this is how you check if homebrew is installed. Which brew? So it gave me directory, this is where it is installed. So that's how we are going to do. So which comma brew, and now we are going to capture the output. Capture output dot run return code is equals to 0. This means that this process successfully executed. So in that case we are going to return yes, we have brew available. Now if system is Linux, which would be mostly other servers, so we can check for the apt directory, which is, let's first check Debian Ubuntu. Now if os dot, so we'll also need to import os. Path dot exist, we'll check if this path exists. Slash user slash bin slash apt. If this is returning, then we are going to return the apt installation. Now we need to check if elif os dot path, let's copy it. And it is in DNF. Then we are going to return DNF. Elif os dot path dot exist slash user slash bin slash pacman. So in that case, you are getting it that we are going to return pacman. So if none of them is returned, we'll just handle the none case. Now this is where we are going to do the installation based on the system that is where our code is getting executed. So now let's again call system first. So svm is equals to platform system dot lower p package manager is get package manager, the function that we just implemented, and we are going to go in a try catch loop if system is Darwin manager is brew, then it's a very easy. We'll just need to execute the sub process dot run brew, comma install, comma tesseract. And we'll just add a check true. So this is how the system, this script will automatically install in the macOS system. Let's build it for the other systems such as Linux when the apt is available. Elif system is equals to Linux, and if package manager is apt, then we are going to run subprocess.run sudo first, because we are installing the package, apt get upd will first update, and then let's check true, then we are going to run the installation. This is the best practices. So sudo apt get install. Let's also give the explicit permission -y Tesseract OCR. OCR, and we are going to do check true. So same thing, now we'll repeat it for the DNF and pacman. So elif, let's copy that. This will be elif package manager is DNF. In that case, we are going to do sudo DNF install -y Tesseract, because they have different naming as per the distribution. So now let's again one more time. If the package is pacman sudo pacman, and then after that the command is bit different. So after pacman it will be -S, and then the confirmation is like no confirm, then you put a comma, after that it is same. Now the only remaining thing is when the system is Windows. In that case, this will have to do a manual installation, because Windows does not allow execute string to install the packages, because by default the security features firewall will block it. users, but in that case we are going to print the instruction, please install from their official GitHub. Which is up/mahim. So from there you can refer how it can be installed. In that case we are going to just return, and then we will before returning we'll just write Tesseract OCR. And in the exception, subprocess called process error as E. So we'll have to specify what happened depending. So right now I'm just going to do sys.exit. We'll also need to import system. So once this is done, I think it is going to install. So let's now test it. Render. Let's see if it installs the tesseracts. So let's do uv run src install tesseract. Okay. So there must be some typo that I have made. So it is saying line number 31. It says platform dot. Okay, so there is two brackets that I need to. Now it is installing the Tesseract. See, this is happening. It automatically detected that I am using the Mac OS and it is doing the installation. So that's how the production systems are built, packages that are built, and this way we are going to ensure our MCP server can be used by anyone and anywhere except Windows for now. But mostly all of the servers are Linux based server, so for 99% of the user it won't be a problem. Meanwhile it is doing the installation. Let's go back to server. So now our code, whenever this code will run, it will ensure that we have the Tesseract already installed. Now let's start doing the implementation. Let's go to initializing our MCP server. So it says Tesseract OCR is installed successfully. Perfect. Now we can start implementing our MCP server. So now let's install the object. FastMCP, we'll name it OCR. And let's define the input type. So let's make class OCR input. is an enum. So what type of input that we are going to support? So it is going to support file, URL, meaning if people can provide URL, then also we can do it, and it can also support bytes. So meaning if you have the image byte already, then you can also use it. File path, then also you can use it, and URL as well. So that's how, like, the flexibility that you give to your any LLM or MCP client, they whatever the data they have, they'll just send it to our server. So now let's define a sync def load image. Because we are giving this flexibility, so we'll need to ensure that we have handled it properly. So input data, this is a union, could be str or could be byte. So if it is an str, then it means this is a local path, or an it's a local path, or it is a URL. So it will return a numpy n dimensional array that we will give it to the our OCR Tesseract. So let's implement it. We need to first thing determine input. This is important because we are giving this flexibility. So if is instance input data is str, and this means it means there is two things. So first we'll see if it is a URL, parse dot URL parser, URL parser, and then we'll pass the input data dot scheme in, meaning it is an HTTP or HTTPS, because what may happen, some systems have their internal networking, so in that case they might also be using HTTP. So now if this is true, then we'll need to collect with HTTPX async client, and we'll need to, in prod you'll have to give a timeout, as client dot get the input data. So now we got the response, and if there is any problem, we'll raise for status, and as if there is no any error, then this line will execute, which is np numpy from buffer response dot content. We want it to be np dot uindate. So now we'll handle the exception. httpx dot http error, meaning we were not able to download the image, so we are going to raise an MCP error. This is important, and the error data fetch image from URL. This information will help any LLM to know that the URL that you have provided either that is not correct, or they'll need to check if the URL is correct, or maybe they can ask user to validate. Now once this is done, meaning we have handled the case where it is a URL, so this, now we are going to check for another case where if it is a path or a directory, so which is pretty much straightforward. Is .path exist, if that is true, try an array numpy array dot from file. We are going to need input data and npy.uint. So that's how it is done. If there is any exception, except SE, now we'll raise for it MCP error, and we are going to raise error data, internal error, failed to read image file, str of error. So this will help an LLM to see what is happening. Now the basic case when it's an byte, so that will be in default else case. So this is the case when it's a byte. So npar dot from buffer, and we are going to give input data, uint 8. Now we are going to decode the image. So we have just the numpy array, we have to decode image from it. So image is equals to cv2 dot IAMEncode. There is a method, I know it, sorry, IAMDecode, np array comma cv2 dot image IAMRead in color. So if image is none, which is a possibility, then also we need to raise the MCP error. Internal error. Image data. And we are going, if this does not happen, then we are going to just return the image. Now we come to the exception. Exception is issue two exception as MCP exception, MCP error, raise it for now, or maybe we can do this way, exception as E, raise MCP error data. So you will become used to doing this, and you will also see the value of doing it, because unexpected error loading image str of error. So this way we completed the image loading functionality, and as you can see we are handling each of the cases like URL, or is it from a path, or we are directly getting the buffer. So now let's move on to implementing the tool itself. So to implement a tool, you do @MCP mcp.tool. So that's how you define our tool. So this is going to be async def perform OCR input data. Let's give it a union of str bytes, because these are the two different types of input. And then you can also specify for Tesseract what language it is. Languages, this is str, by default we'll use English if not specified. And then the config, these configurations are for this is for actually the configurations of Tesseract. So let me do for now just this is going to be default configuration, so we'll only focus on that. Str. Now we are going to, here the docstring writing is important, so we'll have to write a descriptive docstring. So this tool perform so its args data can be one of file, path to an image, or URL, and then draw image bytes. Languages, Tesseract code default, and we will see is the -OEM 3 PSM 6, and now we'll also define the what is it returning. Returns extracted text from the image, and also we'll have to give a usage example. Now see, perform _OCR. We'll have to define the path to .jpg. So that's a example that you'll have to give. It will be helpful for any LLM. Let's also give one example of an image that it hosted on a web server, example.com/image.jpg OCR, and then for image byte we'll just pass a variable image bytes. So I think these are good descriptive argument, the definition of this function. It will be helpful for an LLM, or maybe you can refine it more within ChatGPT or anything. The main objective is the implementation here. Let's first validate the image. Validate language. So we are going to pass so that the errors are gone. Expect. Okay, so all error red lines are gone. That's how I feel comfortable while doing the coding. Now let's start doing the check of the available validate the language. So pytesseract dot get languages. So if languages not in available languages, if the language is not in the available language, then we are going to raise MCP error, because in that case we are not supporting that the language. So invalid parameters, unsupported. So we'll also give the information what languages are available. So this will give our client, MCP client, information that given language is not available and what other options are available. Image, await the function that we have created. Since we have handled the all cases, what possible input can be, so we don't have to worry here. Now let's try to get the text. So pytesseract dot image to string will pass image, langs is languages, config is config. So now at this point we'll get the text. If not, we'll also do some validation. Stop. I mean, there can be a chance that the text is an empty string. strip. Then we are going to again raise the error. Internal error. And the error data. Sorry. So MCP error. Error data. Error data. Internal error. No text. Detected image. And if that is not true, that means we have detected the text. So return text dot strip and exception yeah, so this thing is done. So we'll handle the case where the Tesseract is not working. Internal error, OCR. So do one more exception for the outside one. Exception as raise MCP error data internal error unexpected. There can be an unexpected error. However, you won't see that much during OCR in those most cases we are going to give this information to the client. Now I was also thinking we can also give the tool for the language model to get to know what languages are itself available. So let me define that. So again we'll have to define the tool. Get the list of and it will return, since there is no params, it will return the usage so let's implement. Now same thing, Tesseract Tesseract dot get languages, if not langs, then we are going to raise an MCP error. Now error data, internal error, no supported languages found, please check. Please check the Tesseract installation, and that's all. If everything is fine, then we are going to return the languages. We don't need this pass now. And if there is any other unexpected errors, so we should also handle them. Internal error, failed to get supported languages, str, and yeah, we are pretty much done. Now we just need to make the calling name is equals to under main MCP dot run transport is going to be stdio. So that's how you implement the server. There is one error, let me see where it is. Okay, so it should be no more errors. Now we'll just need to update the init and render main file so that the execution is very smooth. Let's come to render main. So we'll have to do some import arg parsers from .server, import MCP. So def main parser, arg parser, argument parsers, description, let's give it a description, extract text from images using OCR, files URL, so now if render we'll just call the main, and now we'll need to update the init files so that all exports are done correctly. Let's also export the version. Mm-hmm. 0.1.0. This is going to be the first version. From .server, import MCP, perform OCR, get supported languages, and MCP perform OCR. So that's how the complete initialization is done. Now we just need to do one thing. In our the PyProject.toml, we need to define how to start the execution. So if you come here, you just need to define the project dot scripts and MCP OCR is going to be MCP OCR dot main, and that's how you do the initialization of this project. Now this has become a pretty much long tutorial. I will pin rest of the code if I'll put the GitHub link. If you go there, and you'll see the rest of the code is present over here, which is nothing. We just adding the scripts so that we can push this into PyPy. If you see this project I have pushed into the PyPy, so there are some configuration steps that are needed. Why we are doing it, that I'll show you, because now once this project is pushed to the PyPy, then we are going to use it anywhere. So for using this MCP server, we need an MCP client. So let's install Grey Goose. I'll show you how to do the installation. Okay. Sorry, it's a goose. I think it is called Goose. Let's see. We can see if there are multiple one. I'm just, yeah, Goose. So this is the Goose. Okay, I was going to the right directory. So let's go to installation and install for Mac OS Silicon. You can use your other anything that you want, like Linux or Windows, it is available. So once the installation is done, we will do the LLM setup. So for that we'll use the free Grok. Come to Grok, do a sign up, then create an API key. So this is the key that I'm going to use, and let me just put it. Don't worry, I'm going to invalidate the API once this project is up. So I can see our Goose is installed. Now we just need to do the installation. So let's see. Alright, so we have our Goose has been installed. Now we'll use Grok configuration, the API key that we have got. Let's do submit, and we are good with Grok. Now we need to just see. Let's type hi, see if it is working. Do you like to talk about a specific? Alright, so let's come here and let's go to settings, switch provider. There are llama. Alright, now let's go to extension. Now we are going to, you need to click on the click custom extension, and in the extension name is the MCP OCR stdio. This can perform OCR in the images. So now it is asking for the command. So come to this. Since we have pushed our change onto the PyPy, now you just need to do UVX MCP OCR. Let's see. If it works, then this means all setup has been done perfectly. It will take some time. Meanwhile, what I'll tell you what is happening. It is pulling it from the PyPy and doing the installation. Now, because the installation also requires to install the pytesseract, so it is taking time. Yeah, so you can see our MCP OCR just got installed, and let's go in a chat. Let's ask if it is able to discover. Can you do OCR for me? Yep, look, it just takes it was able to connect to the it tried to execute those tools, but let's ask it, can you perform, let's try to give it an image. Let's use this image. What is that? I think I need performance here. Let's create a new chat. Sometimes it does not work. The gray goose. We'll need to change the model. Let's use Grok. Alright, maybe there's some issue with Grey Goose, but that's how you enable it in the, this is how you start your MCP server, and it was able to connect by that. What can you do for me? I think there's some issue with llama key. What can you do? Funny. Maybe I'll need to switch some model. Configure. Switch models. Yeah, so see, it is telling that MCP OCR perform optical of images and documentation. So the MCP client was able to discover it, which is good thing. And yeah, so for the code will be available in the description of this video. You can see already, I am recording this after that I have pushed. Already 2000 people have already using this project, and it's also having some stars. So you can see people are using it, forking it. There are some open issues in the project as well. Feel free to raise a PR, and that's how you build a production grade MCP server. And thank you very much. Leave any question. Please do not forget to subscribe.